VPN technology in Checkpoint firewalls. Hi guys, welcome once again to this new training session. In this section of the training, we'll go ahead and explore and understand the concept of VPN, and then we will proceed on implementing it. So VPN simply stands for Virtual Private Network. Now a quick definition that we could give to VPN would be it's a network on top of another network, or some call it it's a trusted network over an untrusted network, or you can also say it's a private network on top of a public network. Now let me give you a quick example how it works. Let's say this is my public network and I have two sites. These could be routers or firewalls, doesn't matter. Let's say this is my site A, this is my site B, and they are both connected to the public network. And I have a network behind site A, which is, let's say, X, and I have a network behind site B, which is, let's say, network Y. So we already do have this existing infrastructure or this physical public network that we have. Now with VPN, what would we be able to do is we would be able to create another virtual network on top of this public network, end to end, and send traffic from site A to site B. Now it also does not mean that the traffic that goes across this virtual network should be encrypted. You can send unencrypted traffic as well. But as far as you create a virtual network end to end from site A to site B, that would be called as of a virtual private network by simply implementing eternal connection end to end. Now there are two main types of VPN. One is the Overlay VPN, and the other one is peer-to-peer. Peer-to-peer. So what the main difference between the Overlay VPN and peer-to-peer is that in Overlay VPN, the service provider or the existing public or another network that you have would not participate in the routing process of your traffic that is being sourced. Let's say in this case from site A to site B, the service provider would not participate in the routing process. So it's an end-to-end connection. It's an end-to-end circuit that you can call it. However, in the peer-to-peer, the service provider or the existing network that you have, where you would create another virtual network on top of it, the service provider or the existing network would participate in the routing process of your traffic that's sourced from one side to the other side. Now, if I give a couple of examples of the Overlay VPN, one would be, let's say, tunnel interfaces that we may create. The other one would be IPsec. The other one would be, let's say, Ssl Tls. The other one would be, let's say, the Microsoft version of TP, point-to-point tunneling protocol, or let's say L2TP, which is the layer 2 tunneling protocol. And also frame relay, if you do remember, being an old technology where we used to create an end-to-end layer 2 circuit, so the service provider would not participate in the switching process of those layer 2 frames that were sent, let's say in this case from site A to site B. So similarly, the tunnel interfaces would also be an end-to-end tunnel, and IPsec would do the same thing. Ssl Tls would do the same, PPTP and L2TP. Now in peer-to-peer, the service provider would participate once again in the routing or decision process of the traffic that is sourced from, let's say in this case from site A to site B. Let me give a couple of examples here. So MPLS would be one of it. Multi-protocol label switching, which is a layer 2.5 technology, where the packets are switched based on labels. And another example would be, let's say, access list, simple access list or another example we could give to it would be, let's say, VLANs, layer 2 VLANs. Now let me give you a quick brief on the peer-to-peer. Let me just remove this. Let's say I have another site here as well. Let's say this is site C with a network of, let's say, Z this time, and it's also connected to this public network. Now if you if this is an MPLS service provider, what happens is they would have some sort of a device here where they would create VRFs, virtual routing and forwarding tables, for every client. Now if the traffic is sourced from site A to site C, what would happen is that this device would say you are not allowed to go out this direction, you are not, let's say, allowed to go any other direction, you are only allowed to go this direction. So simply we can do the same thing via access list as well, and we can also do the same with VLAN, where we may have a switch here and we may allocate certain number of ports into a specific VLAN so that those devices would only be able to communicate with each other. So that's the main difference between the overlay VPN and peer-to-peer VPN types. Let me go ahead and give put some more light on the tunnel interfaces. Let me remove these. Let's say I would create a tunnel interface from site A to site B, and you will need a separate IPv4 subnet for this tunnel connection. Now this tunnel interface or tunnel connection could be in different modes. The two very common ones are IPv4, where only IPv4 traffic would go across this tunnel connection circuit, and the other one is GRE, generic routing encapsulation, where you may have some sort of a routing protocol going on here and some sort of a routing protocol going on here, where they would exchange routing prefixes using that routing protocol. So GRE could be another one. Now let's go ahead and explore IPsec. Let me clear the screen. IPsec, or some call it Ipsec, by its own self does nothing. It is just a shell where you would add components into it and then go ahead and implement it. And what are those components? Let's say encryption is the first one. Second one is authentication. Next we have is hashing, and next we have is the Diffie-Hellman, and then we have a lifetime and other details for the key. Now encryption is nothing but the confidentiality, and what are the examples of encryption types? This would be one of it. Data encryption standard, which is a fixed 56-bit encryption key. The next one is triple DIS, which is 3 times DIS, so 56 times 3. And the other one is AES, advanced encryption standard, and you have different flavors of 256, 512, etc. bits. And authentication is used for the purpose of authenticity, where two endpoints would authenticate each other using that authentication mechanism. Examples would be, let's say, pre-shared key, or we could also have digital certificates. And we have hash, which is basically used for the purpose of integrity, and examples would be MD5 or SHA-1. We have other SHA flavors as well, SHA 256, 512, etc. I'll give more details on each one of them. Diffie-Hellman is basically the key length or the strength of the key that would be exchanged between two or more endpoints. Now let me go ahead and put some more light on each one of them. Now this being the first one, data encryption standard. So this is not nowadays not commonly being used. Why? Because you can find tools and apps that would easily decrypt or reverse engineer this encryption mechanism. So it's using a 56 bit of the key length strength, and triple days is 3 times the 56, which is 160 bits. AES is using 256 bit, and you also have other flavors of 512 as well, which is AES 512 and others. So when someone says 56 bit, what that actually means, let me open the calculator. Now when someone says, let me convert this to the scientific mode. So if someone says 56 bit, it means that 2, which is the base, the binary base, to the power of 56. So this is the strength or length of the DIS encryption mechanism, but it can still be reverse engineered and decrypted easily nowadays with different tools and apps. So when I say triple DIS being 160, it does not mean that 56 plus 56 plus 56. It means that 2 to the power of 160, which is this amount. So if I open another calculator, so this number means that 10 times 48, which is close to this range, multiplied by 1.461, 1.461. I won't add the other numbers, but it would get close to this range. And we have AES. Let me open another calculator for that. So 2 times 256 is this amount, which is 10 times 77 and multiplied by 1.5 something. Now we also do have other flavors of it, which is 512, which is 2 to the times 512 would give me this amount. So triple days and AES 256 and 512, etc., they are basically secured method or types of encryption mechanisms that are irreversible, or you can say that cannot be decrypted. Now in authentication we have pre-shared. Let me give you a quick example there. So let's say this is my 2 sites, and I would be using a pre-shared key between them. Let's say 1 2 5 6. So the same key needs to be configured on the other side to authenticate each other. And the other one is digital certificate, where we could create our own certificates on both ends and authenticate each other using that certificate. Or we could use, let me remove this, or we could have another trusted CA server that we both would trust and authenticate each other using the certificate that is issued by the trusted CA server. So what is digital certificate? Digital certificate is similar to as of your national ID card or your passport, where you have your photo, the issue date and expiry date of the passport, your signature that you may have, the birth details. Similarly, in digital certificates, we have the company details, domain details, issue date, expiry date, in the signature, the types of encryption, the hash type of the hash that we may use. And we have hashing being another component of Ipsec, which is basically used for the purpose of integrity. And we have MD5 being the first one, message digest 5, which is using 128-bit key strength or length. And we have SHA-1, which is using 160-bit. However, we also do have other flavors of SHA, which is using 256, SHA-512. Let me give you an example of how it works. Let's say I have this being site A and site B. So I have something to be sent from site A to site B. So I will weigh or put this packet into a scale. Site A would put this, and then we'll calculate that it's, let's say, 1 kilogram, 1 kg, and this tag, this 1 kg tag would be attached onto this packet and would be sent across. The other side would do its own calculation, would weigh this and put it into scale. If it's exactly 1 kilogram, it would accept the packet, and if it's above than 1000 grams or 1 kilogram, then it would drop the packet. So this is basically that hash value, or the checksum, you can call it also, that would be attached onto the packet and would be sent across, which is basically used for the purpose of integrity, that the packet that is being sent across has not been altered, or nobody has touched it. And the next one is Diffie-Hellman. Diffie-Hellman is the length of the key. So if I have, let's say, this being a key of 512, and I have this being another key which is 1024, we have different flavors of Diffie-Hellman group. We have group 2, group 5, group 14, and group 21. So the bigger the length of the key, the more secure you are. And we can also assign lifetime to those keys, that how long should these keys be valid under IPsec. And one more thing, we can put these authentication and encryption and hash mechanisms in one of two modes. One is the symmetric one, and the other one is asymmetric. Where in symmetric you have the same key on both ends to authenticate each other. However, in asymmetric you have two keys, basically a public key and a private key. So what are the examples of symmetric? This is a symmetric method of encryption. Triple this is symmetric as well. AES is also symmetric, and pre-shade is also symmetric. However, digital certificates is asymmetric method of the authentication that you would use. Why? Because you would need a public key and a private key. You would need a public and private key. So what the concept here is that if something is encrypted with the public key, it can only be decrypted with the private key. If something is encrypted with the private key, it can only be decrypted with the public key. So let's say if site A wants to send something to site B, if it encrypts something with the private key, it can only be decrypted here with the public key. Now if this guy is sending back encrypting something with the public key, this guy needs to have that private key to decrypt that packet. So that's the concept of symmetric and asymmetric. We also do have another type of authentication that's called RSA, reversed Shamir Edelman, which is also an asymmetric type of authentication that uses a public private key concept similar to as of digital certificate, where this guy was the CA server, and it issued certificate to both of the devices, both of the endpoints, to authenticate each other using those certificates. Now let's go ahead and go through the steps of how to configure it. Let me clear the screen. The first step is to configure an IKE phase 1 policy, which is Internet Key Exchange, and it uses a protocol called Xampp, which is Internet Security Association Key Management Protocol, and it uses UDP port 500. And if you are behind a NAT device, in that case it uses UDP port 4500. So what that means is that if you have this public network and you have your device here and you have another device here, and if you have a device that's doing NAT here, and for this device to make its IKE phase 1 bridge up, what you will need to do is you will need to allow UDP 4500 on this device that's doing the NAT. Now in IKE phase 1, both end needs to agree on a policy and set of rules that what sort of encryption mechanism should they be using, what method of authentication should they be using, what sort of hashing shall they be using, and which Diffie-Hellman group shall they use, and what should be the lifetime of the key. So all these parameters shall be agreed in IKE phase 1 to create a bridge for IKE phase 2 to work. Once the IKE phase 1 bridge is established, then IKE phase 2, which is the IPsec Internet Key Exchange phase 2, which uses IPsec, and there are two protocols that IPsec uses. One is ESP, Encapsulation Security Payload, and the other one is Authentication Header. Now, the difference between these two is that Authentication Header only encrypts the header of the packets. However, this guy encrypts the entire packet, which means that it encrypts the header as well as the payload. This guy is a protocol 50, is using protocol 50, and this guy is using protocol 51. So authentication header only encrypts. Let's say this is my packet, I have this header, so it only encrypts this portion. It does not encrypt the payload. So however, the ESP encrypts the entire packet. It encrypts the headers as well as the payload itself. So once IKE phase 1 bridge is being built, then IKE phase 2 or the IPsec would be able to build another bridge and send encrypted traffic inside it. Now IPsec uses two modes. One is the aggressive and the other one is main mode. Now the next step is to define the interesting traffic. Now what interesting traffic means is that which traffic from source to which destination should trigger my IKE phase 1 and IKE phase 2 to be built. Let's say I have network X here and network Y here. So VPN IKE phase 1 and IKE phase 2 should only be triggered when traffic is sourced from X to Y. If it's not sourced from this to this, then VPN should not be triggered. So, and the next step is to create a policy map where we put all these IKE phase 1, IKE phase 2 and interesting traffic and put this all together, and then the last step would be to apply it on an interface. In this case, it would be, let's say, this interface, or if we are configured on this side, it would be this interface. Now we also need to be careful and consider one more thing in mind, that what sort or type of topology do we have? Do we have site to site to implement our and configure our VPN technology, or do we have a site to multi-site or hub and spoke, or we have a full mesh, or if we are using remote access or Ssl Tls? So let me clear the screen and explain that as well, then we'll go ahead and configure it. So following are some of the implementation types or design types or topology types that we can say. So the first one is site to site, and the next one is hub and spoke, and the next one is full mesh. Now site to site, we sometimes also call this point to point, and a hub and spoke we also call this a point to multipoint or site to multi-site, and full mesh is full mesh. Now let me draw this. Let's say I have this public network again, and I have one side here and the other side here. So if I am making a site to site VPN between site A and site B, this is called site to site. And if I have two or more sites, and let's say this, assuming that this is my headquarter HQ and this is my hub, and all the sites are connected to my hub, in that case we call this point to multipoint or site to multi-site or hub and spoke. So in hub and spoke, what happens is if traffic wants to go from B to A, it will directly go, and if from B it wants to go to C, it will have to go to A and then come back to C. And in full mesh we have direct circuits going on between all the sites, where now if B wants to send some traffic to C, it has a direct VPN tunnel going on, and it will send traffic directly to C. We also do have got something called DMVPN, which is called dynamic multipoint VPN. So in this case, what happens is that the IP addresses that my spokes are taking are maybe DHCP that the service provider is assigning to them, and they are keep on changing. So in that case, the hub or all the sites would dynamically need to create that VPN connection. So we use DMVPN. If we have, this is, let's say, my HQ, we also have something called dual hub DMVPN, where we may have another hub here, and it also has a public connection. So the clients would also create a separate VPN tunnel or session or circuit with that other hub as well, for the purpose of redundancy. So they will have another circuit going on like this as well with the backup hub. Now these type of designs or implementation or topologies are only used when you have multiple sites. Now what if you have remote PCs that are connected to the public network and wants to connect to the headquarter or maybe some site? Now in that case, we have other options like Ssl Tls, that is basically using a browser and access to this portal, and then would provide the credentials and login, and then would benefit the internal headquarter resources. And we have another option which is called remote access. So in remote access, these client PCs would use some sort of an application, and every vendor has its own remote access application. Like Cisco has, Cisco calls it a VPN client, Palo Alto calls it Global Connect, and Fortinet calls it Forti client, and Checkpoint calls it remote secure access or endpoint security. So every vendor has its own remote access application that would allow the end users to access the portal, the headquarter portal device, and provide the credentials and then benefit the internal network resources. So that is the general concept behind VPN. Now let's go ahead and configure it. So I have three sites, this being my central site, the headquarter, and this is site 1, and this is site 2, where they are all connected to the public network, to the internet. And I'll go ahead and implement a full mesh VPN design, where I will configure CPHQ and site 1 and site 2, and I'll also go ahead and create a VPN tunnel session between site 1 and site 2, where the intention would be to encrypt the traffic that goes from the internal subnet of central site to site 1 or site 2. These would be my interesting traffics, which will trigger the VPN tunnels. So I have a subnet of 11.0 in the headquarter, and I have 192.168.1.0 in the site 1 and 192.168.2.0 in site 2. So and I have my PMS, policy management server, here, where all these three gateways are connected to the policy management server, from where we will do the VPN configuration. So I'll smart console to my PMS, which is having an IP address of 192.168.11.11, and I'm using this PC to smart console to the policy management server. So the username is admin, the password is admin123. Let me clear the screen. So I have my Checkpoint headquarter gateway and CP site 1 gateway and CP site 2 gateway. The first thing we will need to do is go ahead and install the VPN Blade, because by default it's not activated. That Blade is not installed on the Checkpoint gateways. So we will go ahead and right click and edit, and you can see all these blades. The only blade that's activated is Firewall. So Ipsec VPN is not installed. We'll go ahead and check this and OK. We'll do the same for site 1 and site 2. So once you do that, you see the VPN Blade icon here, that this blade is also active on this gateway. I'll do the same for site 1 and site 2. And let's go ahead and install this. Publish and install on all 3 gateways. Install. So while this is doing its job, we'll go ahead and do the VPN config. So let's go to the security policies. So as you can see, I only have one management rule that is for the purpose of management for the gateways from PMS subnet. From this subnet to 3 gateways, and I have the other one, which is the cleanup rule that drops everything. So down below you can see VPN communities. We'll click on that. So by default you have 2 VPN community policies. One is for the mesh topology, and the other one is for the remote access clients. If you want to apply these default policies, you can go ahead and implement this. If you want to create a new one, you come here. You have 2 options: star community and mesh community. In star, what happens is you would have a hub and other remote sites or spokes, and in full mesh all the sites would be having a VPN session where they will send traffic directly to each other. However, in star, all the spokes would have to go through the hub or through the central site to reach the other site. So let me click on star community. So here you can give a name to it. Let's say I'll call this star. And here you put your central site, the headquarter, the hub, where in this case would be my CPHQ. This would be my hub. You will add that here. Let's say this is CPHQ here, and you will add all the spokes or the regional sites or the remote sites in the satellite gateways. You will, let's say in this case, add site 1 and site 2 here. So they will make site 1. So it will be like this. And in the encrypted traffic, you can define whether you want to encrypt only the satellite traffic or the center and the satellite. So satellite here means the regional sites, or you can also call this spokes or remote sites, and the center would be the headquarter or the central site or the HQ. So if you want only the satellite sites gateways to be the traffic should be encrypted, you can select satellite only, and if you want both, so you click on both, and here you can log it. In the encryption, you can configure and set your encryption methods. Here you have IKE version 1 and IKE version 2 as an option. So if you want to use IKE v2, so you can select this. If you want IKE v1 and IKE v2 for IPv6 only, then you select this. Or if you want IKE v2 to be preferred but still support IKE v1, you can go ahead and select this one. The difference between IKE v1 and IKE v2 is that this is the older version and this is the new one. The difference is that, let me quickly give you a quick brief on this. So if you are using IKE v1, then in IKE phase 1 policy, what you say, only use DIS being my, let's say DIS or triple DIS or AES as an of encryption method. Appreciate, let's say, for my authentication, and use let's say MD5 for my hash. and let's say use a Diffie-Hellman group of 5, let's say, or 2, whatever, for my key pair. So this is one policy that you would create and send to the remote pair. Let's say this is my one side and this is the other one. So this policy would be sent to this other side and ask the other side if you are using the same policy. We can go ahead and bring that phase 1 bridge if you wanted to. However, in IKE phase 2, what happens is you give more options to the remote end. Like you say that if you are using IKE phase 2, then in that situation, what happens in one policy, you give many options to the other remote side. Like you say, okay, if you are using this, or let's say AES, or if you are using pre-shade and as well as digital certificate, or if you are using MD5, and also if you are using SHA, we can go ahead and agree on that policy. SHA, let's say maybe 512. And for the Diffie-Hellman group, if you are using 5, or let's say maybe 14 or 19 or 20, we can go ahead and bring that IKE phase 1 bridge up. So you're giving, so this guy is giving more options to the other side in one policy. In one policy, it's sending more, it's like a suite of options that you give to the other remote pair. If anyone is, so what the other side may go ahead and say that, okay, I'll select this AES being the encryption and digital certificate as of a authentication method, and MD5 hash and Diffie-Hellman group 19 as of the key pair or the key length or the strength. So they both will then agree on this set of rules and policy, and they will build up that IKE phase 1 policy bridge. Now in encryption suite, let me clear the screen. Now in the encryption suite, if you don't want to make a custom IKE phase 1 and IKE phase 2 configuration, if you don't want to set your own custom suite, you can go ahead and use one of the default pre-configured ones that are already configured here. If you want, let's say this triple days SHA Diffie-Hellman group 2, you can go ahead and select this. Or if you wanted to go with a more secure one, then you can go ahead and select this is 160-bit as of an encryption method, and this is using 256. So you can go ahead, and this is Diffie-Hellman group 2, and this is Diffie-Hellman group 14, which definitely is more secure than this one. And if you want it more secure, then you can go with this one, and if you want it more secure, which is the most secure in the out of these 4 options. Now if you want to create a custom suite, you can go ahead and define your encryption, integrity, and Diffie-Hellman for IKE phase 1 and IKE phase 2, which is IPsec here, and this is for ISA-KMP. And here you define your encryption method. Let's say you select this, or let's say this, nobody uses this nowadays, so let's say AES 256. Data integrity SHA, let's say 256, SHA 384. These are the bits. SHA-1 is 160, and SHA-256 is 256-bit, and this is 384 bits. And Diffie-Hellman group, and you can also see the strength of the length of the key here. The higher you go, the more secure it is. And IKE phase 2, once again, which is using ESP. Here in this case, you would go ahead and define your encryption method for IKE phase 2, and you also define your hash or integrity being SHA or MD5, or let's say AES XCBC, which is the most secure nowadays. And here, so we by default, the IKE phase 2 uses the main mode in Checkpoint gateways. If you want to use the aggressive mode, you can check this. If you uncheck it, the default mode is main mode. And here you can define your PFS, the perfect forward secrecy. which Diffie-Hellman group do you select here. This is basically the PF is used when for every negotiation, when two peers communicate, they should create a new key. So if you don't want to create a new key and you only create it the first time for the first negotiation, then you only use that. But if you want for every negotiation to use us and create a separate Diffie-Hellman key, which would be a good option, then you select the PFS and you define which strength of the key you want to use. And if you want to use IP compression, you want to compress the encrypted packets, then you can go ahead and select the support IP compression. The next is tunnel management. Here you can say whether your tunnels should be permanent all the time, or if you want it, if by default this is unchecked, so you can check this, and if you want that tunnel, once it's up, it should always remain up between all the sites. Or if you want specific gateways to have a permanent tunnels, then you can select this one. Or if you want specific tunnels for the specific communities, you can select them here. And here you can log your tunnel when it goes up or down. And here you can define your VPN tunnel sharing. Like for each pair, should you have a separate VPN tunnel, or for every subnet you should have a separate VPN tunnel. So let's say in this case, if I have another subnet here, which could, let's say, be 192.168, maybe 12. So in this case, maybe 12.0/24. And I'll create a separate tunnel for this, and I will create a separate tunnel for this. So let's go back. Or if you want only one tunnel for each gateway, then you go ahead and select this one pair. Now here it doesn't matter how many subnets you have, it will create only one tunnel between the gateways. Now here in the VPN routing, you can define how the regional sites or the spokes should communicate with each other. Now all the regional sites or spokes should communicate to the central site only, or if you want that other if the remote sites or the central sites, the satellite sites should go through the central site to communicate with the other satellite sites or the spokes, then you can select this one. Or if you want all the traffic that goes to the internet, to the public network, and the central site should go through the central site, then you go ahead and select this one. Now all the traffic that goes for the public, for the internet, or for the other sites, or for the central site will go through the central site. So then you go ahead and select this option. And we have exclude services. And exclude services, if let's say there may be certain services that you want to be excluded from the encryption, then you can add them here. Let's say I don't want let's say maybe telnet traffic to be telnet to be encrypted when going through that tunnel, or maybe HTTP traffic, or Samba traffic, or SMB traffic, or FTP, or whatever. You can exclude that here. Now in the shared secret, you can define your shared secret key. In the wire mode, you can bypass the firewall if you have uninspected traffic that's going through the VPN community. And in advanced, you can define your SA's lifetimes. SA means security association. So you can define the IKE phase 1 lifetime, for how long should they be up. These are in minutes. And how long should the IKE phase 2 security association or SA, this is in seconds, which is 3600 seconds. And here you can disable net inside your VPN community. Let's say in this case, you don't want net to be going on between this subnet and this subnet. So you can disable that for these or for any of the gateway that you want. So you can disable it here, and here you can reset all the VPN properties if you have brought some changes into the essays, or maybe here or somewhere else. Now let's go ahead and I won't save this. Let's go ahead and go to meshed community this time. So we can name it, let's say, full mesh. And here you need to add all the participants that would participate in the full mesh VPN topology. So the only difference you don't see is the satellites here, because in hub and spoke topology we have to define our hub and the satellite sites or the spokes or the regional sites. But here you because you are creating a full mesh between the headquarter site 1 and site 2, so you only add the participants here. So we'll go ahead and add them all. Let's say I have 3 gateways right now, so I'll add them all. And here once again same, you can encrypt the traffic, and here you can define the methods. So the encryption, or if you want to use the suite IPv1 IPv2, so it's same. So I'll leave them as default. In tunnel once again same, exclude services same, you can exclude specific services, shared key, wired method, and the SA lifetimes if you want to change. So I'll go ahead and OK. And if you wanted to come and edit any one of these, you can click, let's say I have this default one, I can go ahead and edit this. If you wanted to use that one, so I can come and edit something, and then I will go ahead and use that policy or profile for my VPN tunnels. So the next thing, we'll go ahead and go to the gateways and servers, right click on the gateway, edit. Now here you will need to bring a couple of changes. The first thing, you need to go to the network management and VPN domain. Here you need to, by default, this is all subnets behind the gateway would be encrypted. Now if you want a specific subnet to be encrypted, in this case I want this subnet to be encrypted when I'm using that VPN. So I will go ahead and select that subnet. So I already have that an object for that subnet, which is 192.168.11.0. So I have selected this. The next thing is you'll click on Ipsec Vpn. So you'll make sure that which method of the VPN community you have added here. So if it's not added, the full mesh or something else is selected, you'll need to come here and add it. And you also need to define the link, and you have 4 options here. They always use this IP address, or use calculated IP based on the topology. This one, which interface is my external, then that interface would be used. Or the other one is, if you have a record for the IP address, then you can use a full name, fully qualified domain name here instead of IP addresses. Or if you are using a cluster environment, let's say you are having 2 or more gateways here, and you have clustered them for the purpose of high availability and load balancing, then you will select that. So I will go ahead and select this one and the main IP address, or you want a specific IP address. So which interface or which IP address do you want this tunnel to be applied on? So in this case it's 291.33.22, which is this interface, Or if you have a statically netted IP address, then you will write that IP address here. So I'll go ahead and select this IP address, which is connected to the internet and is able to reach the regional sites. So I'll go ahead and select this one. In VPN Advanced, you can set whether you want the community configuration for the VPN tunnels of pair, subnet, gateway. You want that to be select it, or if you want to select it here, then you can do that. So I'll leave this as default, and here you can define the wire mode. So if you've brought any change in the VPN community, that would apply on all the gateways. However, here if you select the wire mode, then it will be applied on only this gateway. Now this is the support Net Traversal, which is must for internet traffic. So if you uncheck this, now normally what happens is, if your internal users tries to go out of this interface, all the traffic would be encrypted. Now the internet does not understand encrypted traffic. So if you send a packet, an encrypted packet to, let's say, a ciphertext goes to the google.com or maybe YouTube, they will drop that because they do not accept encrypted or ciphertext traffic or cryptographic packets. They only understand and would accept clear text. So if you want net traversal to be selected, that in that case what happens is that if traffic is sourced from the internal network to the public, it would not get encrypted, the CPHQ will not encrypt it, and if it is distant to the other spoke, to the original site, which needs to go through the tunnel, VPN tunnel, then it will apply that VPN configuration on top of it. So we need to go ahead and select this. Okay. So I'll also go ahead and do the same for site 1 and site 2. Edit. And I'll go ahead and define my network that I need to encrypt, the internal network. So in this case, it is 192.168.1.0, this subnet. So I'll need to create an object for that. So if you can also create it from here or from the object, or you can directly create it from here as well. So I'll go ahead and select a new network object. So I'll call this, let's say, site 1 network. Let's say this is 10. The network is 192.168.1.0 with a mask of 24. Okay. Sorry. So I'll select this. Okay. I think I also need to define the interface link. I'll need to go to the IPsec. I'll make sure that full mesh is there. The full mesh VPN community is there. And link selection, I'll need to go and select my interface that's pointed to the public network, which is able to reach the other sites, or the central site and other sites. This, not the internal IP address. And I'll also need to make sure that this is selected for the public traffic, internet traffic. And the next one, we'll go and do the same config for site 2. So I'll go and add a new object for the internal network of site 2, which is let's say 192.168.2.0, 192.168.2.0 with a mask of 24. Okay, so it's this subnet, and I'm applying it on this gateway 192.168.2.0. This is more of the interesting traffic that I told you. So I'll go ahead and select it, and I'll go and make sure that full mesh VPN is there. And I'll select the interface, this interface, which is 291.33.200, this interface, which is connected to the internet. And this interface would make the VPN tunnel between the CPHQ and site 1. So support Net Traversal is there. Okay, so we will go ahead and install this, publish and install. we also need to go and create. Now this is just the configuration of the properties that we did. Shall we do the let's go and install this, then we go to the security policies. Now the changes that we brought was for the properties of the gateways. Now here you exactly would allow which traffic, which source, from which source to which destination should this VPN be triggered. If let's say source is this, destination is this, in this gateway, then it should trigger the VPN tunnel. Now where do we define that? We need to go to the security policies, and I'll create a new rule above the cleanup rule. Let's say in this case new rule above, so I'll call this, let's say, VPN traffic, and on the source I'll add all three subnets. If traffic is sourced from this subnet or this subnet or the central site, the HQ network, all these three, distant to any one of these three, again this, and my central site, which is this. So if traffic is sourced from any of these sources to any of these destinations internal, then go ahead and, so this is when, if this is not showing, you can go ahead and right click and select the VPN column, and then here you select, right click and define which community member you want to use. So I'll go ahead and click on specific VPN communities. So these are the available ones right now. These are the two default ones, and this is the one I created. So I'll select full mesh for which application and service. So right now I'll leave this as default for any service and any application. The action would be accept. I'll log this so we can see some log messages in the logs and monitor, and we'll go ahead and install, publish and install this on all three gateways. Install. So let this policy installation complete. I'll go and assign IP addresses. Let me check if I have IP addresses assigned here on my site 1 and site 2. So let me just I hope you are able to see the topology. I'll make sure that I have my IP address. Properties, no, I do not. So I'll say static, and the IP is 1.2, the gateway is 1.1, and the DNS is multisym.com, and the DNS IP is 11.10, which is this DNS server. And okay, I'll connect this. Let me go to the PC2 of site 2. Which is 2.2, and gateway is 2.1, the domain name, and the DNS, which is 11.10. Okay, and connect. So let's go ahead and see if the policy installation has succeeded. So here you can see it has succeeded. Now let me go ahead and try to ping and try to reach let's go ahead to client 1 first. From here I'll open my terminal and I'll try to ping one of these IP addresses from this subnet, which is 192.168.11. So if I say ping 192.168, let me ping, if I can reach my gateway first, 1.1, which is this. So I'm able to reach. Yeah, it's good. So now I'll ping 192.168.11.12. let's say in this case maybe this Windows PC. So I'm able to reach there as well. So you can see that we will check VPN now in the smart dashboard of the PM policy management server. But let's go ahead and test from PC2 as well. So I'll go ahead and open the terminal. I'll ping my gateway first, if I can reach my gateway 2.1. So I can reach my gateway. I'll ping 192.168.11.12, which is this IP. I'm pinging it from the PC2, so I can reach there as well. So I'll also try pinging from site 2 to site 1, which is this PC, and the IP address is 192.168.1.2. My IP is 2.2 and the site 1 PC1 IP is 1.1. So 1.2. So I'm able to reach there as well. So I have a full mesh VPN topology. So I have a VPN tunnel or session like this, and I have a VPN and tunnel session like this, and another one like this, which is a full mesh. Now let's go ahead and see logs and monitor if I'm having some encrypted traffic. So let's go to the smart console, logs and monitors. Refresh. Let me remove that filter. So I should see some VPN traffic here. So this is some traffic that is sourced from 192.168. Let me double click on it. So this is UDP traffic. Let me check the ICMP. So let me go ahead and filter it. So service is ICMP protocol. So here you can see I'm using the this one. I'll open this one. So from site 1, I'm using VPN Blade, and the traffic was sourced from this IP address 2.2. It is a reply, I think it's a response back to site no, it is the origin is site 1 CP, and the source was 2, and the destination was, yeah, it is the echo message. Yeah, it is the echo request, not the reply. So it was sourced from this IP to the external zone, destination this IP to the internal, and it was ICMP. The blade was VPN. It was decrypted. The action was decrypted because site 1 has decrypted an encrypted ICMP echo. So that's why it says the lock is open, and it shows me the origin is site 1, because the traffic was sourced from here to this destination. This guy decrypted that ICMP echo and forwarded to the PC1. So that's why it's showing me site 1. So these are the details. VPN traffic is the access rule name. in the policy security policies. This is the access rule, and if you go to the matched, so it's accept, the action is accept. So let's go to the new tab here and to the tunnel and user monitoring. Which takes me to the smart dashboard, the smart view. Now here you can click on the VPN. So right now you have 3 tunnels that are up, and if you click the Ipsec VPN here, so from here you can see some encrypted throughput going on or decrypted. Let me go ahead and which site is this is site 2. I've selected site 2. So if I start a ping there, so these numbers would go up. So let me go to PC 2, and if I resume that ping, so you can see these numbers are going up. So from here you can understand that encryption and decryption is going on. And if you come to the tunnels, okay, which gateways do you want to select? I want to, let's say, select the N1, let's say headquarter. So right now headquarter has two tunnels, that is from CPHQ to site 1 and site 2. The state is up, the community is full mesh, the peer IPs are these, and these are the source IP is this. And if you come here, you can get the details here, the full mesh, let's say tunnels on community. So I have 3 tunnels right now in this community. So the state is up, community name is full mesh, type is regular, and they have tunnel going on like this. So from here you can check the tunnels, whether they are up, encrypting and decrypting. Let me go ahead and try to capture some traffic and see if I'm able to see something now. Let me go ahead and let's say there is someone on the internet and tries to capture my traffic that's sourcing from any one of these sites to any destination. Let's say I'll capture from this interface, which is towards site 1. So I'll say E01, this interface. Okay, open, and I'll try to browse my I have Apache Xampp server installed on this client PC. So if you come here, let me make sure that the service is started. So I already have installed the Xampp server here, which is a small application that uses Apache, MySQL, FileZilla, Mercury, and Tomcat. You can use this tool. It's a good app. You can use it for the purpose of web services. So let me go ahead and go to my client PC, this one, and I'll browse that. So let's say this, I have my application server or database server installed on this maybe PC or server. I have a host a record pointing to this, which is app.motasim.com. So you can see I'm able to browse my application server. So Xampp server. Now let's go ahead and see what have I captured here. Or maybe this is some intruder sitting on the public network or internet and has captured my traffic. So it's all ESP. He's unable to it's between site the source is, let's say, this one. So the intruder would not be able to get any clue of this ESP payload. So it's just ciphertext, and the intruder would not be able to understand anything out of this encrypted ciphertext. So that is how you configure VPN on the checkpoint firewalls or gateways. Thank you.